Hello students, how are you? Welcome to this new video of my lesson motion, and this is going to be the part 6 of this lesson. Okay, and by the way, this is going to be a new part, or it is going to be our last part, okay, of this lesson. And by the next video we will actually start one new lesson. That lesson is nothing but the actually next lesson of this physics part, forces and laws of motion. Okay, and in this video we are mainly going to discuss some problems that are in your exercise part. Okay, maybe in your part 3, okay, of these videos, I have actually discussed first 3 problems related with velocity, acceleration and speed. And we will discuss now from question number 4 to question number 10. Okay, now we will basically start from the question number 4. So I will first write down the question, then I will try to solve it. Okay, so just be with this video and watch the video quite attentively, because these questions are going to be very much important regarding your final exam. Or okay, and those kind of exams were mainly because of your knowledge. Okay, it will increase your knowledge, it will boost up your knowledge. Okay, those formulas that you have got, the equations of motions, that v equal to u plus at, s equal to ut plus half of at square, then one more formula that twice as equal to v square minus u square, right? All those are going to be used, right? So open your book when you are just watching this video, then match up those formulas and try. If you want to try it by yourself, just pause the video at this moment. When I just write the question, just pause the video and try it by yourself, then watch the video. If your answer is correct or not with me, okay, then as like that, I will actually continue the class. Okay, and then it will be some quick introduction one, right? Since I'm not doing some kind of live class, so as like that, I have said it is going to be some kind of good interactive class. Okay, so just bear with this video. Okay, now we will start from the question number 4. This is our question number 4. What this question is actually saying that, look closely, that a motor boat starting from rest, one important thing, starting from rest, that means what? U is going to be 0, right? Since it has been starting from rest. On a lake, accelerates in a straight line, that means we have got that the car is actually accelerating in a straight line, but it is actually accelerating. The main thing is that at a constant rate of 3 meter per second. That means acceleration has a constant rate, that is, it is in uniform acceleration. Okay, that is 3 meter per second square, right? For 8 seconds. That means we have got the time also, t, right? Now the question is, how far does the boat travel during this time? That means how far means what we actually calculate, the s, that is the distance or a displacement, that is what you can say, does the boat travel during this time. Okay, now we will write down what is actually given. We have given that u is equal to 0 meter per second because it was rest before starting. Now the rate of uniform acceleration is given, a equal to what? 3.0, that means almost 3 meter per second square. And the time is given, that is the nothing but 8 seconds. I will not write the 8.0. Okay, if you want, you can actually write. Now what you have to find? You have to find the s, right? So u is given, a is given. So we have almost 3 relations, that v equal to u plus at, second is s equal to ut plus half of at square, right? And the second relation is one more relation, twice as equal to v square minus u square. Okay, now the thing is, we don't need to find out what actually the final velocity is, right? We have only need the how far that boat actually traveled. So what do you think? Which relation you should actually use? We can use 2 relations. You can use this relation also and this relation also. But the thing is, for that we have to use the v. Okay, we have to find out first, we have to find out v, then we have to add like that. So we will use this relation. It will be better, s equal to ut plus half of at square, because we know the a is given, t is given, this u is also given as 0. So it is quite simple. So distance s will be ut plus half of at square. Simple formula. U is given as 0, so we can write 0 into t into 8 plus half is also half. A is given as 3 and it is also given as t equal to 8 seconds. That means you can write 8 square. So give a bracket. Since all are in meter, their distance will be in meter. We can write, right? So 0 into 8, 0. So don't need to write. It is quite actually not need to write actually, because 0 into 8, if we add something with 0, it is going to be that quantity. So we'll not write. We'll simply write 64 meter, because 8 square equal to 64, right? Now we will actually cut it down. Okay, 3 2, that means 3 into 32 meter, which will be almost equal to 6 into 96. That means the distance as will be 96 meter. Quite simple. Just pause the video and write this down. This is our question number 5. Okay, now first we will see what this question is actually saying. This question is actually saying that a driver of a car traveling at a 52 km/h applies brake and accelerates uniformly in the opposite direction. Okay, uniformly actually accelerated in the opposite direction means it is getting retarded, right? So okay, it is uniformly accelerated in the opposite direction, right? The car stops in 5 seconds. That means it getting retardation, in undergoing retardation, then at a certain point or at a certain time it gets stopped in 5 seconds, right? Time is given, speed is also given, right? Now again it is given that another driver, okay, going at a speed of almost 3 km/h, right? One more speed is given, 3 km/h in another car, applies his brakes and stops in 10 seconds. Again one more time is given. Now what we have to do, we have to do that on this same graph. Okay, we have to plot this in a speed versus time graph, okay, for the two cars. Which of the two cars actually travel farther after brake were applied? That means we have to find out that between these two cars, who have actually traveled a long distance after the brakes were applied. So to actually understand this, first we will plot them or plot these two cars in one graph. Okay, then that graph will be speed versus time graph. So this is one graph. In the y-axis direction, we'll keep speed. Its unit will be meter per second. That means what? We have to first convert this 52 km/h and 3 km/h in meter per second, because it will be actually easy for us to convert them and to actually plot them. Now the actually in x-axis direction it will be time. It will be in second, because all the times are given in second. That's why you have to convert this 52 km/h and this 3 km/h, okay, into in time actually. Okay, so now we will actually convert them. Okay, what is actually given? The first velocity is given as, we don't need to write actually. First we will convert 52 km/h. Okay, if we convert them, it will be almost like how much? 52 by 1000 into 1000 by 3600 into meter per second. If we actually solve this, okay, I have already solved. So if you actually solve this, it will be almost 14.4 meter per second. And our actually the second velocity is given as 3 km/h, right? Now I will actually again convert this to meter per second. Do it simply. 3 into 1000 by 3600 meter per second. So now cut this to 0, it will be almost 3 into 10 by 36, okay, meter per second. If you again solve it, it will be almost how much? 10 by 12. And if you write this down, it will be almost 0.833 meter per second. 0.833 meter per second. So you just write this down. Now we have to plot two actually velocities, or two cars velocity or speed and motion in a single graph, right? In this y direction it will be speed, and in the time x-axis direction it will be time. So since we are only given two times, 5 seconds and 10 seconds, so we'll plot like this. It will be actually good except for ours, 5 seconds and 10 seconds, because there's only two time needed. Okay, so if the readings are small, then it is actually good. Now look carefully about the speed. Highest speed is 14.4 and the lowest speed is 0.833. So we will divide like that. We have to move a little bit like that. 4, 6, 8, 10, 12, 14 and 16. These are the readings in this y direction. Now we will plot. First is given as 14.4. That 14.4 will be almost, is the 15, it will be here, almost here. So we'll draw this line, okay, because it is in the negative actually in the opposite direction. That means it is getting retarded. So it's finally at a certain moment it has a velocity of 14.4. At the 10 second it got the velocity as 0. That means its final velocity, you can say 0. initial velocity here was almost 14.4 meter per second. Okay, it got accelerated in the opposite direction, right? Now, this one is the first thing. Again, about what is actually given. Sorry, it is in 5 seconds. Sorry. I actually mistaken it. This graph should end here. Okay, it should end here. Okay, since it was in 5 seconds, I just actually mistaken. The graph should end here. So it is the final velocity. Initial velocity, the final velocity will be 0 here. Okay, clear it because and it is actually accelerated in the negative or in the opposite direction. Now, what about the second speed? It is given 0.833. It will be almost here. If it is 1, 0.833 will be here. So again, it has ended its journey after 10 seconds, right? So our graph will be a little bit look like that. Okay, this is one curve and this is one curve. So I will give some name. Give this as A, O, B position. Okay, where it is the 5 second, and C, O, D. Now look closely. We have got 3 triangles. Okay, we have got 3 triangles, not 3, 2 triangles. One is AOB, another is COD. We have got 3 triangles, 2 triangles AOB and triangle COD, right? So we need to find out how much distance it actually covered or how far it is actually covered. So in that case, always remember, in that case, we always need to find out the areas, okay, under this line, under this straight line. So now what will be the area under this straight line? Will be the area of this triangle. Okay, this is the area of under this straight line. And for this triangle or for this straight line CD, what will be the area? This will be the area. So we need to find out these 2 areas, then we will be able to find out the how far it actually traveled after the brakes is applied. Okay, now first we will check about the first triangle. That is, the triangle is given as AOB. So area will be how much? We will write the formula, half of what will be the base OB and what will be the actually perpendicular? This is the OA, right? Give the values. OB has the value of 5 and OA has the value 14.4 in meter per second. So second will be cancelled out and there will be only live in meter. So now just solve it. 7.2 and just multiply it. It will be almost 36 meter. Okay, for the triangle AOB we have got 36 meter. Now for the triangle COD we'll check. Okay, so we have just, I will just write it down, 36 meter. Okay, I will just erase this part and I will check for triangle COD. Now we will check the area. Okay, we will check the area. What will be the area here? Same formula, half of what is the base CD. Now what is the perpendicular OC, right? Now write down half into what is the CD is given 10 and what is the actually OC will be how much? 0.833, right? 0.833. For our convenience, what we will do? We will multiply these 2 things. What will be there? 8.33, right? Now again, if we further solve this part, it will be in meter. It will be in meter. If we further solve this, 4.16, almost this 4.16 meter, right? And for this we have got that 4.16 meter, right? Now simple thing, right? So this is the thing. We have got that one is 36 meter, other one is 4.16 meter. So now look closely. Which of the triangle have higher area? Almost actually 32 meters difference, almost, right? So what we can say that triangle actually AOB has higher amount of area. That means what? Which car actually travel higher distance or how further actually move further after the brakes apply? Obviously this car, this first car, okay, this AB line, right? This is the part where he have actually covered a higher amount of distance. Now look closely. I actually told you the concept of slope, right? By looking at it, without solving, okay, if it is a question, MCQ question comes, okay, or consider as an MCQ question and the graph is actually given and you have only given some options and a car A or car C, right? Like that, if it is given, without solving, you can actually say by calculating or by observing the slope. One slope means what? The line, okay, that is actually making angle with the base. This line making angle this much, right? It will be almost, I am saying, it will be almost your maybe around 60 to 70 degree, right? Now this angle is, it will be almost how much? 20 to 30 degree, okay? So what you can say, which line has a higher amount of slope? This line, AB line, that means what? This AB line have traveled more distance or farther, actually move farther compared to this line, CD. So the car which have the velocity 52 km per hour will move farther after the brakes has applied. Students, this is our time to solve the question number 6, okay? This question is actually giving us some graphical representations of one question, okay? So before that, first we have to actually observe what this question is actually saying. That question is actually saying that some actually figure number is actually given, that is showing that the figure shows the distance time graph of the three objects A, B and C, right? Now that I have said that study the graph and answer the following questions, okay? So before that, okay, so we have to solve these things. So our first question is actually, which of the actually three traveling lines, which of these traveling lines are having some higher speed? That means there are actually three lines are given, na? This is B line, okay, this is the B line actually we have given. Then actually we have the C line is actually we have, another one is this A line. Now once maybe in the part 4 of the motion lesson, I actually told you that which line is going to have higher amount of slope is going to have what? Is going to have obviously some higher amount of speed, right? So now look here, this is the slope, okay, this is the slope of this B curve. Consider this is a θ1, right? And to find the slope of the line C, we first have to draw one base here, okay? If I draw that, okay, this is going to be θ2. θ2 means always represent θ1, θ2 and actually θ3. Theta is the angle that the line is actually making with the base, right? And if I change the first color, so, and this is going to be our new base of the line, what? A. And this is going to angle, okay, θ3. Okay, these three are the angles that A, B and C are actually making. Okay, A is making θ3, okay, then B is making your angle θ1, right? And actually angle that C line is making angle what? θ2. Now from figure, okay, from figure, if you clearly want to observe, okay, what we can actually say that θ1, okay, is going to be greater than θ2 and θ3. That means what you can say that for the curve B, it has the highest amount of slope, okay? So we can write that question is which of the three is traveling the fastest. We can say that B, right, is traveling, right, fastest. You can say that B is traveling the fastest. So now why I'm actually using the laptop, see there's a board. Actually in the board this kind of graphs are not quite actually possible to draw and to make you understand, right? So basically what you have understood that in this question, our first question was going to be that we need to find a slope. If we are able to find the slope of the three lines, okay, or three cars we can say, then we will be able to find the highest speed car. Consider that there are three cars, B, C and A, right? B is making highest amount of angle with the base, okay? After that we can see the C, it is making the say θ2 angle which is little bit smaller than the θ1. Right now for A, it is making angle θ3. So that θ3 is the more smaller than θ2. That means what? θ1 is the greatest. That means B is making highest amount of angle with the base. That means what? B is going to have highest amount of speed, right? So this is the correct answer. Now, what question B is actually given, that are all three ever meet at the same point on the road? That means three cars are given, right? A, B, and C, or you can say simply B, C, and A, right? In the second question, they have asked that are these three cars going to meet at a certain point, right? This is the question, okay? So what we have to observe that, look closely. This is the meeting point of what? B and A, right? This is the meeting point of B and A, right? Now, this is the meeting point of what? B and, sorry, this is not B, actually, I actually mistaken. Okay, this is the meeting point of B and C. This point is the meeting point of B and C, okay? Now, this is the meeting point. This is the meeting point of B and A, okay? Now, and this is the meeting point. This is the meeting point of what? Simply C and A. That means at this point, okay, you can write, give them some name, 1, give them name as 2, and give them name as 3, right? At the 1 number position, two cars B and C is meeting, clear? At the 2 position, B and A is meeting, and at the 3 position, C and A is meeting. If we clearly observe this figure, we can clearly say that there is no extra points, okay, where 3 cars are meeting at a single point, okay, at a single time, right? So what you can say that question was actually, are all 3 ever meet at the same point? That means the answer will be no, because there is no single point that where the 3 cars are actually meeting, right? This is the answer. Now we will move towards the, okay, you should actually write this question answer. It will be quite beneficial for you. What will be the answer? There is no single point, okay? There is no single point where the 3 cars or points are actually meeting, okay? Clear? Simple question. Basically, the question number C of the 6th number question is actually asking us that how far C traveled, that is the C line, this C car actually, okay? That C car actually traveled when B passes A. So for that, first we have to check at which position B will actually pass C. So we have to find out that position. So here, this is going to be the position, right? This is going to be the position where B will pass A. So at that moment, then we have to find out where was actually C. So before that, first we will draw one line, okay, one normal from this position to actually at this line, okay? So this line is actually giving us the point or the time when B passes away A, right? So at that point, where actually C. So if you clearly observe, this is going to be the point, okay, where actually C was at the same time, because we have to find out that how far C is traveled when B passes away. That means when means what? Time. Always remember, if the word when is given, that means what? We have to find out the time. So and this is the time, right? This is the time, okay? This is the time, okay, when B passes away A, right? When B passes away A. So at that time, C was here. So if we need to find out the distance of C when it was at that position, so we will again draw a line. So this is the position, okay, when B passes A, right? This is the final position, okay? This is the final position actually. So what was the initial position of A? Sorry, what was the initial position of C? So this was the initial position. This position was the initial position, right? So we can actually write as the initial position. Now we have to find out a difference between the we need a difference from final to initial position. Then we can actually find out how far C actually traveled when B passes A. So if we clearly see that distance, that final distance has the value of 8 minus, right? What was the actually C? at the initial position. How much distance it actually covered initial position. So for that, we have to calculate it how much distance this x1 square box actually giving us. 1, 2, that is almost there is a 7 box, right? So if there is 7 box, one box will give us 4 by 7, right? One box will give us 4 by 7, right? So how much box is actually covered? 4 boxes actually covered. So what will be the total distance? 16 by 7. So if we minus 8, or if we minus 16 by 7 from 8 minus, okay, so we will get then the distance, okay, how much distance is actually covered when B passes A. So what will be the distance? 56 minus 16, okay. Then if we find out the distance, it will be almost 0 and 4. That means 40 by 7 meter, or you can say the kilometer, since the unit is in kilometer. So how far C traveled, or C actually covered when B passes A, the distance will be 40 by 7. Okay. Now I think you have understood what actually that question is actually asking. Okay, this is the time when you have to find out the question number D of 6 number question. Okay, it is actually asking that when B passes C, okay, when B passes C, how far it has traveled. Now for that, we have to check that what is the meeting point, or what is the point, or in which position actually B passes C. So that position is going to be this one, right? This is going to be the position when B passes actually C, right? This is the line C and this is the line B. So we need to find out the time, okay? So this is going to be the time where actually B passes A, not B passes A, sorry, B passes C, right? So at that time, where was B? If you need to find out distance, this is the point, or this is the line, or this is going to be the point when B passes C, it was here. So for that, we have to again find out. So, and this position actually, this is the final. So, and this 0 is going to be the initial position, right? This is going to be the initial position. But now we have to actually find out the total distance that actually it covers when B passes C, right? So for that, we have to actually find out that how much boxes are there, square boxes. 1, this is the 2, this is the 3, this is the 4, this is the 5, this is the 6, this is the 7, okay. Here in total distance is 4, so each box will carry 4 by 7 units, right? So how many boxes are there? There will be almost 9 boxes. So if one box carry 4 by 7, so how many units we will cover? 9 boxes. 4 by 7 into 9, that is, it is going to be 36 by 7, right? So what will be the distance? Okay, what will be the distance? The final distance has a value of almost 36 by 7, and this initial position has a value of almost 0. So we have to minus 36 by 7 minus 0, then we are going to get 36 by 7. Okay, this is a simple question that we have to actually find out, right? So this is like that you have to do. Okay, so this is the end of your question number 6. I hope you have understood. Okay, this is our next question, the question number 7. Okay, what this question is actually saying? This question is actually saying that a ball gently dropped from a height of 20 meters, right? So then the point is, at least I will explain what is the height. In what will be height here, I will say you that. And the second thing is if the velocity increases uniformly at a rate of 10 meters per second square. Now the unit is meter per second square. That means what? 10 meters per second square will be acceleration. Now it's actually asking that with what velocity will it strike the ground and what will be the time at that actually when it reaches the ground. That means what will be the time then. Simple. Now we'll first draw it, then I will try to solve it. Okay. This is the ball. Okay. This is the ball. From here, okay, it is dropped to the ground. Okay, this is the ground. Okay. Now what is the distance from here to here? 20 meters. Though it is mentioned as a height, height means what? The distance from this ball to the ground is almost what? 20 meters. So we can consider it as a S. though it is given as a height, it means what? It is a distance between ground and the ball, right? So we can consider it as a s. Okay, now the acceleration is given. Acceleration is given how much? 10 meter per second square. Now there is one condition. Okay, I will consider that the direction of the acceleration is ground, but I will consider this direction as a positive direction. Okay, so since the direction of the acceleration is towards, I have only considered that positive direction, so other quantities will have to be considered as a positive one. So if you want to consider the direction of the acceleration as negative, so based on that, other quantities direction will also change. Okay, simple thing, right? So again, at this position it has 0, because if I consider the ball like that at a certain height, so at this position the ball will be at rest in my hand. Once I drop the ball, then it will attain some or increase some velocity, right? So at the air or in the air it will have some velocity. Once it reaches ground, again it is going to have 0 velocity, right? So things are like that. Okay, now we'll solve this. A is given, we have got u as how much? 0 meter per second, and we have got that s, it is almost 20 meter, right? Now we will solve this. We'll use one formula, v square minus u square equal to twice s. Now we can't use that formula that s equal to ut plus half of at square, because we don't know the time. We have to calculate the time. So we will use the third formula of the equation of motion. Now use this v square equal to, right? U square is 0, right? So you will use only twice as. Now put the values 2 into a is given as 10, and so s will be 20. Okay, so now v will be 400. V square will be 400 and v will be plus minus 20, right? Once there is a square term in the unknown value, so it will have a two probable values, that plus 20 and minus 20, right? Now the thing is, the signs will come here. I have told you that I have considered in the downside direction all the quantities have to be in positive. So we can't consider the negative sign. So we will only consider the positive sign. That means v will be 20 meter per second. So we have got that with what velocity? Once when it just touched the ground, it had a velocity 20 meter per second. But once it settled in the ground, it will have 0 velocity. So don't confuse about that. The moment when the ball touched the ground, okay, so it had a velocity 20 meter per second. But once it settled down in the ground, it is going to have a 0 velocity, because it will be at rest once it reaches the ground. But the moment when it touches the ground, it will have a velocity 20 meter per second. So don't get confused about that, okay? So now we got the velocity, okay? Now we will, okay, calculate the time. What will be the time when it actually reaches the ground? So we got the v, we got the u, right? Then we need the time. We had a formula that acceleration a equal to v minus u by t. We will use this formula to calculate time. Just replace the positions. So t will be v minus u by a. Here u is 0, so we don't need to write that, because if we minus something 0 from something, we are going to get this. So we got v as 20 meter per second, and we've got acceleration as how much? 10 meter per second square. Meter with the will be cancelled out, and there's 1 meter per second, 1 second inverse, and there is 2 second inverse. So between that we will remain only 1 second, so it will be 2 seconds. So we got the two things. Quite simple question. Just write this down. Then we'll move towards our next question. This is the time to actually have to find out the area of some area where we have to find out the question number 8. Okay, that question number 8 is actually saying that the speed time graph for a car is actually showing in the figure 8.2, right? This is the actually figure where the actually speed time graph of a car is actually given. This is the curve, okay? This is the curve who is actually giving us the speed time graph, okay? So, and this is the base where the time is actually given. This is the base where the time is actually given, okay? And this in y-axis, the speed is actually given. Now, in the first question, it is saying that find how far does the car travel in first 4 seconds. So where the first 4 seconds is? This is the first 4 seconds. Okay. So to calculate this, first we should draw one line from here to 4. Okay, this is going to be one line. Again, when we have discussed the speed time graph, velocity time graph, acceleration time graph, actually in case of the velocity time graph, if we need to find out the actually displacement or area, okay, or how far it actually covers, it's a distance, right? So then we have to find out the area under this curve, right? If it is the curve, okay, we have to find out the area under this region, okay? But look closely, this is not actually given any kind of geometrical shape. So for that, okay, for the convenient to solve this question, we will consider that this is a geometrical shape, and we will consider this geometrical shape as nothing but a triangle, okay? So this is only for convenience, so you have to just consider it, otherwise you will not be able to solve this. So you have to consider that, considering a triangle, okay, we have to consider a triangle. So what is the area of the triangle? We know the formula, half into base into perpendicular. The perpendicular is written by like that. So now we'll find out what is the length of the base. What is the base is given? How much base is given? 4, right? And what is the perpendicular length is given actually? If you clearly see, this distance is nothing but almost approximately 6, right? It will be 6. So it will be in meter. So cancel out 2. That means it will be almost 12 meter. Okay, 12 meter is the distance that the car actually travels in first per second. So first part is actually solved. Now it is actually saying that set the area on the graph that represents the distance traveled by the car during this period. So this is the area, okay, that we have to actually set like this. We can actually set like this, okay. We can also set like this. So this is going to be our area where the actually car traveled in the first per second. So simple, this question is done. So now we will move towards the next part, okay. Then before that I will erase something, then it will be actually helpful for you to understand, okay. So this is the area that I have actually solved, okay. Now I will choose one different color, then it will be clearly feasible for you to understand, right? What this question B is actually saying us that which part of the graph represents uniform motion. Now we have to understand that for actually uniform motion, right? For uniform motion with time, okay, if the time is passing with time, the speed, okay, the speed should be constant. That means the time will change, okay, the time will change like 4, then 6, then 8, okay. First it is in, consider that it is in 4, then it is moved to 6, then it is moved to 8, okay, like that, okay. In the x-axis the time is actually changing, but with that, if the motion is uniform, okay, then the speed will remain constant if the time changes. Now look closely in the graph, okay, from this position, okay, from this position, if you clearly observe the graph, this is the portion where the speed is remains constant, okay. So we have to actually, if we actually set this part, then it will be clearly visible for you to understand that which part is actually representing the uniform motion, right? So this is going to be the part. So again, if we set this part like that, giving some random lines, okay, this will mean that we have actually set this part, okay. So these are the parts which is actually representing that uniform motion of the car, okay. From where the time is actually changes from almost 6 to 10 seconds, right? So this is the answer of this question. This is our last question of this lesson, okay, of the exercise part. And what this question is actually saying that an artificial satellite, like we have some normal satellites are there in the surrounding of our Earth, and again we know that Moon is our own natural satellite, right? So as that man-made satellite actually are known as the artificial satellite, okay. So an artificial satellite is moving in a circular orbit of radius 42250 km. We have got two information, that circular orbit or circular track or circular path, and the radius r is actually given. So we need to calculate the speed. Right? If it takes 24 hours, that means we have got the time also 24 hours to revolve around the Earth. So we need to calculate this speed. Simple circular track, right? So what will be the distance? The circumference, okay, of this circle. So if this is the center, right? So consider the earth as a, this is the earth, okay, and maybe this is the satellite. Okay, now we will just write down what actually given. Okay, so first radius is given 42250 kilometer. Okay, we'll convert this to meter, so we will write down like this into 10 to the power 3 meter, because in 1 kilometer there is 10 to the power 3 meter, so we can write 42250 into 10 to the power 3 meter. So we have got time t equal to 24 hours. So in 1 hour the time in second is 3600 second, that means 3600. So what will be the second in 24 hours? 24 into 36 second. Now we got r, we got t. Okay, we need to find out the speed. Okay, I will actually represent the speed as by p. Okay, one formula that we have got twice pi r by t. Now put the values. Okay, 2 into pi, you can actually keep the pi value as 22 by 7. I will give that value as 22 by 7. Okay, into what is the r is given? 42250 into 10 to the power 3. Okay, now what is the actually time given? 24 into 3600. This is meter, this is second, right? So we will just arrange this. Okay, so it will look like somehow this 42250, and since that 7 will come down, 24 into 7 into 3600, and we will write the 10 to the power 3 here, and the unit will be meter per second. So if we try to solve this thing, it will be almost you can write 1859000. Okay, I will still solve it down already. Okay, so that's why I can actually write it. Otherwise, if I try to solve here, it will take lots of time. That's why I still solved it. And if you try to solve this one, so it will almost 604800 into 10 to the power 3 meter per second. Again, if I solve this thing, okay, it will be almost 3.07 into 10 to the power 3 meter per second. Okay, so we have got, this is the result. If you solve till now or till this, so your answer will be correct. But in your NCERT book, the answer is written in kilometers per second. So if I write down 10 to the power 3 meter, it will be almost what? 1 kilometer. So what you can write as 3.07 kilometer per second. Okay, this is the answer of this question. So just write this down. Okay, so these are the questions of this lesson. So we have actually discussed all the questions of the exercise part. Till now in this video, we have actually discussed all the problems, okay, from your NCERT exercise book. And these problems are actually basically needed for your exam purpose and for your concept purpose. So in exam, do not think that the same question will come in your exam, but this type of question will come. Okay, and from this concept, the question will be there. So just go to the video properly, okay, and once you watch the video, just open your copy and note this down. And if you just open your book, your NCERT exercise part, then it will be beneficial for you. If you do not understand any word from my video, then you will be able to see in your book. Okay, same question is given in a book in the exercise part of the lesson motion. Okay, and in today's video or in the today's part of this lesson, the video is completely ended. Okay, but by the next video, we will start our next lesson, that is nothing but the fourth session, laws of motion, and that is having some kind of connections with this lesson. Okay, that velocity concept, that acceleration concept will be there little bit. Okay, so before actually we should start that lesson, you just go through all the parts again. If you just interested in this part, or if you're just interested in my video, just go to the videos again. Then you will actually gain some knowledge and gain some concepts, and that concept will definitely help you. You know, higher studies, like when you go to your higher secondary level, this lesson is going to be there. So in this level, you should actually have some basic ideas, so it will actually benefit for you. Okay, right? So we'll actually meet in our next video. By the way, till now, if you have liked this video for whatsoever reason, just hit the thumbs up button or the like button and just subscribe to this channel. Okay, and this subscribe or this like will give me some motivation to make more good videos, right? More some innovative videos, okay, to give you some knowledge. Okay, so till then, stay happy, stay healthy. Bye bye.